All right, so this is number 10 from page 193 now, okay? And again, this is asking us to kind of come up with an equation for a rational function with, again, some conditions. But it wants us in that form, kind of like ax plus b divided by cx plus d. So what I'm going to do is just try and like write some factual statements based on the conditions that I see there. Okay, I'm just going to write a list of factual things that I think will lend themselves to us trying to like solve this puzzle, basically is what this is, right? So I'm going to maybe go from the bottom up, but I think you could probably start with any of the conditions, right? So I know the horizontal asymptotes. In order for us to have a horizontal asymptote non-zero, so a horizontal asymptote that isn't y equals 0, the degree of the numerator in our rational expression must match the degree of the denominator, which is what I can kind of see there, right? So that must mean that the ratio between, so for the horizontal asymptote, okay, the ratio of A over C must be 4/3, as per what it tells me there, right? That in addition to that, we would get the next condition, the vertical asymptote. The vertical asymptote would come about in the event I had a restriction in the denominator. And basically what I have there is cx plus d has to equal -2/3. Okay, so there is a little bit of like, we can deduce what's going to happen here, but I think there is a bit of like, there is some mechanics that we could follow, right? And what I'm going to try and do here is figure out how I can get each of these components to make sense. So if I treated, you know, A over C is 4/3, or I could also have like 8/6. It could be any number of these, right? But we're trying to find the balance of these kinds of things so that these two up top still make sense as well. Okay, so what I'm looking for here is, I know that I'm going to treat for a moment that A over C is 4/3. Okay, and so I'm just going to rewrite my function as 4x plus b over 3x plus d. Okay, and that kind of takes care of the horizontal asymptote. Okay, and then what I'm going to do is say, like, if I treat A over C as 4/3, then I'm going to try and like solve for what d would have to be in order to give me a vertical asymptote of -2/3, right? And it tells me that x is -2/3. So look, so if I know 3x plus d, if I say x has to be -2/3, oops, then I can solve for d. If the denominator is in fact equal to 0. Okay, so remember, a vertical asymptote occurs when the denominator is equal to 0. And so what I can do is just input 3 times -2/3 plus d is going to equal 0, and I can solve for d. So I'm going to get -2 is going to equal -d, and so d is going to equal 2. Okay, so we got one more component to solve for now, right? So basically, if I rewrote my equation, it's starting to look like this. F of x is equal to 4x plus b over 3x plus 2. Okay, and you can see there that if I input -2/3 in for x, I'm going to get 0 in the denominator. Okay, so there's your vertical asymptote is right there, right? Where 3x plus 2 can't be 0, right? Now we got one more thing to solve for. Okay, and it's the x-intercept. So I think we could do the same thing with the x-intercept up top, right? So in the bottoms tell us about vertical asymptotes, or holes, restrictions specifically. Okay, and in the top, that's where we find information to deal with x-intercepts, right? So if 4x plus b is equal to 0, because that's what it means for it to be an x-intercept, where are the y values 0? Then I can solve for b. If I know, again, the x-intercept's at 1/4, so I can go like this. 4 times 1/4 plus b is going to equal 0. The 4's are going to drop out. You're going to get 1 plus b equals 0, and so b is going to equal to -1. So here is the final equation. F of x is going to equal 4x minus 1 over 3x plus 2. That satisfies all of the conditions that have been specified within our problem. Where there are, oh, one more, the y-intercept. That's the last tricky one, right? So the y-intercept must spit out -1/2. And you'll see, like, I think the flow there, the way I've kind of like targeted these conditions, you can see the y-intercept has naturally just fallen itself out, right? So if I say the y-intercept happens when I evaluate the function when x is equal to 0, so I get 4 times 0 minus 1 over 3 times 0 plus 2, you can see there that when I evaluate the function at 0, I get -1/2, which is what we're looking for. Okay, so that might be, I think the big pillars of these rational expressions are the asymptotes, so that's where my eyes went to, and then I can find some points on the graph. That's kind of the natural flow of what we did in class, and some of those points are the easy ones to find, like x-intercepts and y-intercepts, and so that would be the way I would try and structure the development of an equation like this, is to work with the big features of horizontal and vertical asymptotes first.